All right. So let's talk about how to use AR, AI, and sensors to create population-scale solutions. Now, who remembers Ethan Hunt from Minority Report and are big fans? Very explicit interaction. And who remembers Theo from the movie Her? Right? Very implicit interaction. Both of them are trying to capture the action, the digital and physical, and create an experience for either Ethan or Theo. The question for us is the future of AR and VR is going to look more like, for Ethan, or augmentation that's more like what's for Theo. So who's in the Ethan camp? Minority Report. Okay, and who's in the Her, Theo camp? All right, interesting. And that's what we are at. This is the battle, the explicit versus implicit way to interact with our digital world and how it's going to amplify our augmentation. Well, what about Google Maps and Waze? Who likes the reds and the greens of the traffic on Google Maps? Right? And the reason why we can see that is not because we have smarter cars or the city somehow suddenly has built a 5G infrastructure, but it's because we, all of us, are contributing to this data. And as you know, this is the secret behind the new wave of AI, which is the data that's bringing in this augmentation. So what would be a Waze for us? I'm going to take example of surgeons, right? If the surgeons want a Waze-like experience, as they're operating, the surgeons, can they get an experience saying, hey, this particular path has more complications, and this other path, based on prior experiences, is actually a safer path. And in addition to that, given the particular anatomy for this patient, this is what you would learn from millions of previous surgeries that have been done before. So for that, we would capture millions of videos, have library of complications. We would use techniques in AI and have tips and anomalies, and finally create really great interactive experiences. So what's important to realize for AR and VR is a little bit about interaction, a little bit about analysis and intelligence, but the real focus has to be intelligence amplification. The benefit of these platforms is that they are not just a display platform, but they are also trying to deeply understand who we are. Our cognitive abilities, our eyes, our voice, the context, and the action, right? And this is a very rich stream of data that can be used in some amazing ways. One of the startups from a group is called ARINACTION, which is looking through a VR headset to get eye tests for optometry and ophthalmologist. Another startup from here is React, which is doing neurocognitive assessment by, again, looking at the eyes and the voice and action. And in fact, Shahid, Azim, and Sean are here from the company as well. So this is kind of an interesting world we live in, where we thought VR and AR is about Ethan-like interactions, but we are doing something else. In fact, my own PhD thesis at UNC Chapel Hill, almost 20 years ago now, was about augmenting surgeons through X-ray vision. And as excited I was about the optics and the display and interaction, I think we were kind of missing the boat, even back then, right? First of all, in my thesis, I realized that it's not just about the headset, but it has to be multimodal, right? The interaction has to be multimodal. And when you think about AR, we want to be able to sense beyond human ability, but then abstract and present well within human comprehensibility, right? And so we end up focusing on this input, analyze, output paradigm. But again, we are missing the boat because just obsessing on the things that we obsess about today, such as resolution and field of view and quality of optics and frame rate, is not really it's not really the most important thing. In fact, all we are doing with that is kind of finding the dips in the physical, our perception, and bringing them some physical tricks so that we can overlay information and still create an illusion of realism. And in fact, the reason I went to UNC Chapel Hill to do PhD in computer graphics and AR and VR was I was inspired by Jurassic Park. I said, wow, we can create this very realistic dinosaurs with the right reflection and refractions and shadows and scale and perspective. But near the end of my PhD, I saw South Park. Who is South Park fan here, right? I mean, come on. It's cartoons, no shadows, reflections, it's all kind of ignored, and it's all about storytelling. And in fact, South Park is the reason I left the field of computer graphics and AR, VR as we know it. Because it's that moment of South Park versus Jurassic Park. What really matters? And I went through a whole cycle over the last 20 years of what it really means to do intelligence amplification. And people like James Favarda now at UCF have talked about this. In AR and VR, we focus on the photorealism and some physical realism. South Park is more functional realism. But even storytelling, even textual storytelling, is non-visual. And the reason I think we are hampered in the progress in AR and VR is that we have some archaic notion of neuroscience in these fields. The research can almost all be thrown out, and we have to start from scratch in what we need to do. Very few data sets, unlike the work that's going on in machine learning, and the understanding of perception is based on devices that are not as ergonomic as we see out discussed today. So that's the realism in the bottom left here, the non-visual and functional, is what often matters when we're in the real world. Again, going back to surgeons, the interaction with intelligent devices, their perception, multimodal, multi-format, the gestures, the ergonomics, the hygiene, these are the factors that matter the most, right, for that realism. So the question is, for multimode, first of all, we have to get away from this obsession of headsets, right, the bricks in front of your faces. So this brick VR and brick AR is the wall that's made of, right? Those bricks have to be broken down. So if you want to create realism, in this case, visual realism, we have many opportunities in the retina, in the glasses, at arm's length, on the screens, and maybe directly on the objects. And these are wonderful opportunities, but let's not get too narrow and focus on only one type of augmentation when we have all these possibilities available to us. And that's what our group has been exploring, and you should look up our book on spatial augmented reality that's available for free now. And just to make sure you're familiar with spatial augmented reality, which some people now call projection mapping, is actually a fantastic paradigm to bring realism in the real world, especially in a multimodal way, for adding new virtual reflectances, illumination, motion, and completely new types of physicality for interaction. All right, so let's come back to surgeons, right? So of course, by using this mechanism, the surgeons can share tips and work with others, and we can declutter the environment that you see. You can see in this particular cartoon, all the complexity near the surgeons can be moved out. You have cameras and light sources in the ceiling. You have virtual information, which is multimodal on the headset as well as in screens and also at arm's length. Somebody else can dial in, shown here in pink. And these can be completely new environments that we can build. But let me come back to the important message, which is display is not as important as capture. In fact, one would argue that companies like Google and Facebook are a major player on the internet not because they have a browser, not because they're exploiting the browser, but because they're exploiting the mouse, right? Where you click, who do you friend, what do you like, what do you search for is much more important to create trillion-dollar businesses than selling a browser. And it's not about the AI that we think about today, but it's about intelligence amplification. So in the beginning, you can imagine for surgeons, again, any AI or AR project goes through 3 phases, kind of capture, analyze, and interact, right? And in the beginning, you could imagine the life of surgeons will improve through better haptics and sharing tips and training. And it could be transformed over time, as we saw earlier, with library of complications recorded with video and haptics, better interfaces that can allow them to look at anomalies, post-operative complications, and comorbidities, and so on. But then we can insert other layers of intelligence on top of it. Think about an anatome, which sits somewhere between a phenome or a physiome and data at the cellular or cellular or molecular level. And the anatome can allow you to understand the structure, the function, the development, and evolution of various anatomical parts. And that could come through a CT scan or MRI, but this ability to understand the network of how different anatomical parts work with each other would be part of this anatome. And a combination of Waze and anatome then comes closer to how you think about driving today, right? Because we'll have ability to think about it remotely. We can have a population health solutions that are based on understanding of millions of people who might have gone through that surgery, and create precision health solutions where even a surgeon can do novel surgeries without significant training. So our group, Camera Culture, which is right down here on the second floor, is all about thinking about this intelligence amplification, which requires us to make the invisible visible. And when it comes to capture and analyze and interact, we're thinking about new types of cameras that can see around corners, new types of endoscopes, or moonshot projects like how do you see under the tissue, new types of automated and private machine learning that will allow us to use the data without revealing the trade secrets and HIPAA complications, as well as new types of telemedicine and predictive diagnostics. So before I conclude, I want to thank all the people at MIT and my previous life at UNC and Merle along these things. And before I conclude, who's a fan of Prometheus here? Right? Okay. Yes, the robots could eventually do the surgery for us, and they won't need an AR and VR, like we see today. But again, I think we are thinking about problems that don't exist yet, right? I think we have plenty of excellent surgeons. We need to train more surgeons who could use new AR and VR tools. And I feel like a mentalist here because my message is right out here. It's AR for intelligence amplification, AR for IA. Thank you.